now, so I'm ready to go. I prepare a short presentation because it's on a topic I don't know very much about. And so I'm hoping you guys can help me, and maybe some of you, or at least one of you in the audience, have some more experience about this topic than I do, and can hopefully educate all of us. But I think it's when I learn about this topic, which is very recent, in one of the, I do news reviews of studies that come out for cardiovascular disease, and when this one popped up, it really caught my attention, and I think it's already affecting the way I live my life. Is that I think that significant. So I want to share that with you guys, and then talk about how we can change our lifestyle maybe towards this. So I'm going to start by giving you the medical research that triggered the thought, and then at the end I'll propose the thought, and together hopefully we can figure out how do we all can contribute to having a better lifestyle that affects our cardiovascular disease, understanding that this is early research. So there's always this big jump between the early research and kind of, is there a clinical trial that shows the benefit? And the answer is no, because this is very early very early translational research is what we call it. But I think it's exciting and interesting enough that we should all of us start thinking about it. So the title is Plastic and Cardiovascular Disease.
Could I put this under the table?
You shall decide that by the end of the presentation.
Plastic bottles are theoretically not part of this campus. If you go to a vending machine, to the student union, you don't buy plastic bottles.
How
They
do you
don't sell
hide?
plastic bottles.
There's no way of hiding this.
You're not going to get busted for having one here, but just allowed. They don't sell them. And if you buy water at the union, I think it comes in a metal bottle, right, or something.
Vending machines.
Yeah, they don't have plastic in them. They probably don't.
When did they start doing that?
I just can't speak to that. No, they have. I've seen water here in little metal cans, little short, like aluminum cans. So FYI, Javier.
Yeah.
You're doing just fine, but there's a bunch of deaf people in this room.
Got it.
And here's the microphone.
Be delighted.
There's
Without pain that way.
Yeah.
If I'm not looking at you, it's because I'm aiming to the microphone right there. So this is a slide that kind of is shaped by the research we're doing right now at UC Davis. I'm part of this is a big study. It's called the Precise Me study. And a lot of the presentations you'll hear me giving over the next 2 to 3 years will be related to this study. I've already done a few, you may not know that. But the idea here is that cardiovascular disease is the result of an interaction of many things, not just your body, not just what you eat, which or how you feel that day. It's actually the combination of all of them. So the result of health and or cardiovascular disease is the product of many things. That this little cartoon in the middle is intended to do that. So here you are, and when you get pulled by different things, then you're not, if you're in the center, well balanced, you're healthy, but your environment may be one of these things that pulls you and then takes away your health. It could be the biology, maybe your genes, maybe some other variation in biology. It could be psychosocial, it could be anxiety, stress, loneliness. We talked about many of these topics over the last couple of years. So really the study is intended to evaluate the contribution of the psychosocial stress to this balance here. And so we're doing these, all of these are a lot of surveys for psychosocial stress that we're doing. And so in a future presentation, I'll bring that because I may ask some of you to participate and contribute with the surveys. And then we're also collecting biological samples, and some we have 2 projects that are related to animal studies, which are correlating the same thing we're evaluating on the humans, and we're going to correlate this in animal studies, be able to get more detailed biological analysis. And at the end, we hope to bring it back to the human, where once we understand our perceived stress, the factors that are affecting us externally, we call it the exposome, whatever we're exposed to, how it affects us, then we can then understand how to either prevent it or treat it. That's the global concept here. So today, it's going to be about environmental. We have crowding and noise here as to environmental exposures that we put in the grant. But as I already alluded on the title today, the environmental exposure will be plastic. So this is the article that caught my attention. It's from the New England Journal of Medicine, and over the years, you probably have heard that this is one of the prominent medical journals. That doesn't mean they always get it right. I can point a few times when they've got it wrong, but most of the time, the science that gets published here is well evaluated, peer reviewed. So the title is Microplastics and Nanoplastics in Arthroma and Cardiovascular Events. So it's a correlation study. They're correlating microplastics and nanoplastics to cardiovascular events. Arthromas is a big word. It really means mush in your arteries or plaque, the cholesterol plaque. That's what that means, arthroma. So they specifically look at patients with carotid disease. So the carotids are the arteries that go to the brain. And when they build up plaque, they're the ones that give you stroke. So it is usually related to stroke. And patients who have these obstructions, they get to a point where the surgeons have to go in and clean them up, essentially. So it's a true cleanup of the artery. So they open up some space so blood can get through. And then with medicines, we prevent that the clots form, and then we essentially prevent stroke that way. So normally, medically speaking, people get referred to a surgeon to operate on the carotid. So in this study, what they did is they basically took the junk that the surgeon removed from your artery of the patients that were in the study, and then they analyzed that. And that's kind of the schema of the study. And so the data, the information we have is from patients who went to surgery with plaque and cholesterol buildup in their carotids. And when they took that out, then that was, and instead of going through the trash can, which is what usually happens, these scientists were clever enough to say, hey, wait, put it here. We're going to take it to the lab and study it and understand better what built up that plaque. That was what they were doing. Now, microplastics and nanoplastics are things we don't, you don't walk around drinking coffee and say, hey, well, how's your microplastic today? So I figure I'll try to show us what microplastics are in 90 seconds, a 90-second video. And it is an advertisement video. So full disclosure, I have no investment on the advertising, but I thought it kind of creates the point by images fairly well. Before I start the video, can the people at home see that?
Yes. We can see the slide, the title.
The slide, yeah. So we're working on for you to see the.
Yeah.
Yeah, let me get out of here. And share, sharing screen again. Where'd the share screen go? Where's the share screen go? Yeah, please. Yeah. 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 Let's go to the video. So it's here in Firefox. Perfect. Okay, so can the people at home? Yeah.
Yes.
So, this is from the National Ocean Service. I didn't vet them. I don't know who they are.
Plastic is everywhere. A lot of it ends up in the ocean. Most plastics in the ocean break down into very small particles. These small plastic bits are called microplastics. Other plastics are intentionally designed to be small. They're called microbeads and are used in many health and beauty products. They pass unchanged through waterways into the ocean. Aquatic life and birds can mistake microplastics for food. Research is being conducted, but there's much we still don't know. In 2015, the US banned the use of microbeads, but microplastics are still a huge problem. You can help keep plastic out of the ocean. Remember, reduce, reuse, and recycle.
click the swab. All right, so that's what microplastics are, is the product of regular plastic, and nanoplastic or nanoparticles are built that way for some commercial purpose usually. Even had toothpaste is what they had on the video. But they get small enough they can get anywhere. And so you can find them in the body of persons and animals. They even cross the placenta into the baby. So for the mother consume, baby gets microparticles. So, and so I was doing my research about this, and again, I'm just learning about this, but it caught my eye that babies that consume microparticles or microplastic have low birth weight. And so, you know, we talk all the time how the United States don't do so well on their birth rates and the healthy of our babies. And I wonder whether all of us drinking out of plastic may have something to do with that. Just a thought, just a wondering concept. So there's a lot to be learned here. But let me talk about what we do know, which is the study. And so let me describe the study. So it is a prospective, multi-center observational study. So they didn't do anything to people. People were just having their surgery done. Patients went for their surgery, and the reason for surgery, they were asymptomatic. So these were not people who had had strokes. They were preventing a stroke by having surgery. So that's the group that they approached for this. And so what they did is they, again, took the carotid arteries from them. I mean, the plaque from the carotid artery was removed and then analyzed. Now, when they get enrolled in the study, we don't know whether they have microplastic or not. We don't go asking people, did you drink water from a bottle? So what they did is they analyzed the plaque from the people that came from the people, and then they looked for the microplastic in it. So they didn't know when they signed up people for the study, which group were you going to be. They found that out afterwards when they did the analysis in the laboratory. And so they did the analysis in 3 different ways. These are big words. I'm not sure I can explain what this means. Pyrolysis gas chromatography mass spectrometry. So if there's a student in the room that knows what that is, I'd like to listen some more. They do stable isotope analysis and then electron microscopy. I'm going to show you some pictures of the electron microscopy. It takes a little imagination, so I'm going to try to help you see it, to understand it. And then so that's how they look for, this is how they look for the plastic in the material they got from the artery. And then they also measure standard analysis for inflammatory chemicals, inflammatory markers that we do. And this is very commonly done in many different situations. And what they did is then they separate the group into 2 groups, the people who did and the people who didn't have particles in the artery. And now they end up with 2 groups to compare. And so they compare one group to the other. And the assumption there is that if you have microplastic in your carotid artery, you were exposed to it. And if you didn't, then you were not exposed to it for whatever reason. And so that's the experimental design. This just kind of says the same thing, but in boxes and whatnot. And so they end up with 150 people who they found have microparticles in their carotid artery. They had 107 people who did not have it. So those people theoretically, or presumably, were not exposed to the microplastic. So then they quantitate 2 kinds of, so this is the group, this is the 58% of the people who did have some microplastic in their arteries. Then they quantitate how much they had for 2 kinds. This is a chemical and plastic, and this is actually the microbeads that were mentioned. And they look at how much they have in quantity. So really, really big distribution of on the right of people exposed to microbeads. Kind of a little bit more homogeneous, if you will, in terms of the regular plastic exposure. So this is just kind of understanding the distribution of how much. So really variable for these microbeads. It's kind of what I took about that. This is fairly homogeneous. Like this is more kind of a yes or no. And this is like a yes, how much? A little bit and a lot kind of thing. Yes, sir. In medicines,
Yes.
Very possible. Yeah, no,
You're looking at.
yeah, no, it's very, very possible. And again, I'm learning about this. I haven't done a thorough review of this yet, but yeah, it's very possible.
What was the question?
The question was, what's the possibility that these particles of these microparticles are present in medicines or medications that are tubing and things like that that people are exposed through medicine? And the answer is very possible, but I don't know that as a fact.
One thing I'm noticing in polyvinyl chloride is PVC. That's
Yes.
PVC pipe. That's the plastic that we ingested as teenagers.
Yep.
Polyethylene is the non-reactive, more food-oriented container.
That's right.
And that might explain why you have more there because the PVC has been removed from the diet, but it might be in the pipes in your house.
That's right. Yep. And we'll talk about that in the table, who these people are, but I'll prelude, the average age is 70 plus. So these are people who've been around for a long time. So they may be exposed to PVC, even though may not be around too much now. And we don't know how long these things lodge in your body and stay there either. So it's possible some of this was exposed 5 decades ago and it just lives there. So all of these are good questions and possibilities. All right, back to what the study did show. So here's a table about that. So you're not supposed to read this, but at the top it's age, it's 71 and 71 is the average age between the two groups. Unfortunately, 77% male. Again, that's a failure of humanity to always exclude the women. They were not that obese. The BMI was about 28 equally. But the point of this table is to show there were no major differences. So they couldn't find something in the standard kind of history. These are essentially all the things that cause heart disease and plaque on the arteries. And when they look at all the different things and the medications people take, there was nothing to really say, aha, that's why you got plastic there. So it's not really, what they're basically saying is the standard things we look at for risk of people did not account for whatever differences we saw in the study. Okay. So this is what the electron microscopy looks like. And so it's a little bit of an artistic picture. So I did some doctoring of the picture to help us. So this is a picture in an electron microscopy of a cell. This is a single cell. And so what I did is I drew in blue, this is me doing, in blue the edge of the cell. So that's the edge of the cell. And these little white stuff in there are normal stuff that's supposed to be there. They're globs of fat that are in there. They live there. They're supposed to be there. There's nothing abnormal about them. But then there's these things in there with the dark rim. That's not supposed to be there. And so that is, and that, there's a black arrow, and I couldn't see the black arrow so well. So I circled the black arrow, so you know there's a black arrow there, and it's pointing to this thing in here. And these kind of dark rim, lighter color in the middle are the particles that they're calling attention to. And they're inside of the cell. This is a macrophage. This is a cell that's responsible for inflammation and cleaning up stuff in your arteries. So likely this cell just chewed up something from outside to try to clean it up. And then it lives with it in it. And then this is the picture looking at outside of the cell. So this is this cell. Again, the blue lines kind of show you with the cell. And here's another cell down here in the bottom right. And then there are two arrows in the middle. These are particles that are outside of the cell in this space between the cells. So the plastic is in the cells and outside of the cells. Essentially, it's all over your body. And it has the ability to go in and out of the cell. That's the other part, the other thing that we learned here. So it gets into your body and essentially can distribute anywhere. And this is found in the plaque that came out of the carotids of these people. So this is a different kind of imaging. This is a scan microscope. And they're trying to show, so again, it's hard to see, but the white stuff is the particles that are not supposed to be there. And they put two little boxes here for us to see that. They picked the cell, so it's hard to, you can't see this in this picture, but there's a cell there. I drew the red line there for you to see the cell. And they pick a cell that didn't have too many, so when they blow it up on the right side, you can actually see. And I put the arrow there. That is in there, and that is in there. And so these are the particles that are not supposed to be there. That is abnormal. That doesn't usually, it's not biological, it doesn't exist there. So they're able to see these again within the cell by a different imaging technique. Okay, so I show you they have some chemical analysis, and then they have actually visual analysis that these particles are inside of the plaque patients. So how does this translate into the outcome of people? So everybody had surgery, everybody did well after the surgery, and then for 34 months after, they look and see whether people had a stroke, a heart attack, or died. So it's a composite, you had one of these to count as an event. And so that's the primary endpoint of the study, is the time to having one of these events happen. So everybody at time 0, it's the time on the bottom, the x-axis, at time 0, there's 0 events. And as time goes by, the number of events start happening, and so the lines start going up. The blue line is the line of the patients without the microparticles. These are the 107 that they found no microparticles. And the orange line is the patients who had microparticles. And what you see is that these curves start together, and about 10 months, they start separating. So the people who had the microparticles at the time of surgery, they went on to have more events 3-5 years down the road. So in other words, they're trying to say, okay, well, we see a correlation between having more events and having this plaque in your artery. They also look at the inflammatory markers in the artery as well to see whether maybe inflammation was part of the cause or the mechanism to this. Yes.
Separated into with and without, what about people who are in between?
They broke down the people as a yes or no. So either you had 0, and that's 107 has 0, no microparticles, they're the controls, and then people who had some, and then I show you the gradation of that group. So yeah, there are huge variation in that group, but they're all, in this analysis, they're all in the orange line, correct? So, and the point they're trying to make is if you were in that group, you have more events over the next 5 years. This is just to show the inflammatory markers. So the blues, again, are the people who didn't have microparticles. And in comparison to the orange have in all these are different inflammatory markers that can be done in the blood or can be done in the artery where they got the tissue. And the people with microparticles have higher, again, a gradient distribution, but in the average, it was clearly higher from the people who had no plastic. So again, it gives one more information about what's different about them. Their age, their medicines, their history of diseases were not different, but their inflammatory markers were different. So in summary, patients with carotid artery plaque in which the microparticles were detected had a higher risk of a composite of myocardial infarction or heart attack, stroke, or death from any cause at 34 months of follow-up than those whom microparticles were not detected. That's the conclusion of the study. It's an association study. There's no causality, so they're not inferring that they know the cause of these events. They're just saying they're associated. Evidence of greater inflammation was found in the arteries with the microparticles. So other known risk factors were noted not to contribute to be found differences between groups. So when they control that graph, when they control for diabetes, hypertension, all these different things, cholesterol levels and whatnot, when you control for all of that, the difference remains. So it just supports the idea that the difference may be coming from the microparticles, but I want to emphasize this is association study. It's not doesn't prove the cause of the mechanism. So that leaves us with the question of treatment and prevention, and this is where my presentation ends. Now it's a free conversation.
Report environmentally where these people are coming from, right? The people that have more plastics grew up in Louisiana versus California or anything like that.
There were multiple centers, and I don't. That's probably a supplement of where the different ones came from. Yes.
Allowances for the microparticles were inhaled, were they taken in orally, were they taken in some other way?
Yeah.
Versus,
They don't know, because the only way that people are in the group is based if they found the microparticles in the artery. The people who woke up the next morning after surgery had no idea which group they were. And so this is not an evaluation of their exposure per se. It's an evaluation of once they had already the disease, the cardiovascular disease, whether the particles were there or not. That's essentially the extent of this. So there's a lot of excitement behind this, but there's a lot of precautions that this doesn't really prove yet the exact what. There is a lot of other data before this for exposure from the air, inhalation, and from food and from water. So there's a lot of that out there over the years. I think this is apparently the first data point to truly show in the same person the evidence of disease with bad outcomes and the microparticles in the individual person. So it's kind of starting to become kind of strong data to say, we got to pay attention to this. It'll take years to figure out in detail the medical science of this, but it's going to take us decades to clean up the mess of this. So I thought we might as well start talking about it. Yes.
Are there any other involved that they were looking for? Because I'm thinking cancer is rising as well, and particularly with PVC.
Yeah.
Remember when they took it out of the drop of capsules, capsules because of cancer threat, not because of cardiac threat. So were they looking strictly for cardiac ends, or were they looking at the broad spectrum of mortality?
Yeah, so they use the all-cause mortality component there. So any cause, but they didn't qualify what were the causes. So I don't know the answer. Maybe everybody died of cancer, and we don't know. That's a great question. But for this, sometimes the studies are done just for cardiovascular death, which is much more narrower.
Yeah.
But here they took the broader any cause of death. So maybe that knowledge, maybe that's known. It wasn't in this publication. So I don't know how we're going to treat this, because I don't know how we're going to ever remove microparticles inside of our cells and our tissues. So I think this is going to be one of those where we're going to really have to work on the prevention part of this. It's really try to keep it from ever getting there. And so that's going to be our burden, is figuring out how to prevent this. But
It isn't lead, heavy metals, it's plastic.
yeah. It's a reminder that we came from living out in the jungle and the forest, and that's right. And eat apples and use leaves to floss. Yeah. So any other thoughts? What about at home? Anybody has any questions or anything? So I pull out one more graph that I didn't put in the presentation because I didn't have time, but I think it's worth discussing it. Let me bring it up real quick. So the question I had is, where does this stuff comes from? So this is not about the study. This is not the cardiovascular study. This is from a different study looking at globally, where does microparticles come from? And so this is the global primary plastic production. So they come from plastic, but where's plastic? How is plastic produced in the world? So they're measuring this in million metric tons according to industrial sector. So this is where it's produced. And so the blue, so each color is a different thing. So it's textiles, industrial machinery, consumer, institutional products, electrical and electronics, building construction, transportation, and packaging. I guess consumer and institutional products is probably where water bottles fall, unless anybody else has any other suggestion.
Packaging.
Packaging, I guess water bottles fall there, that's true. So
Which color?
is the blue, it's the largest, that's packaging.
Taking the bags and go.
It's
off.
kind of almost 50% of comparison to everything else. The second biggest is building and construction. And then the other ones are fairly similar.
A lot of fast food, store-bought fast food
So from,
in plastic containers.
yeah, that's right. So when you ask the question, how are we gonna prevent this, where's the low hanging fruit? It's in the packaging. So if we wanna make for actions we take, probably the larger impact will be in packaging. Just I thought it would be food for thought. No pun intended.
We can't get plastic particles to the food supply.
So, plastic bags were going away, and then COVID came, and now they're back.
They're back because we're afraid of touching other people's. So this is waste generation, same paper, looking at the same things. So what generates waste the most? No surprise, is packaging. So we produce more from packaging and we waste more from packaging. So, and it's huge. So, I mean, this is larger than all the other ones together. And this started in the 1950s because I guess we didn't start to accumulate too much plastic. We used to make things of metal and they used to last. Just so you know.
Yeah.
Your washing machine lasted for 20 years, not for 2.5 years. And half of the parts are plastic probably. So when you think again, where the waste come from, is from packaging. And recycling is so small in comparison to the magnitude of this. I have another graph showing that. But recycling, I mean, we can do all the recycle. All of us go from you doing the recycle to get your entire family to recycle, and we still wouldn't budge the numbers. Recycle is just such a small fraction of this. So in the magnitude of thousands. So I think it's 1/8,000. No, 1/800th of the plastic gets actually recycled. So it's a huge amount of it never gets there. Yes, sir.
It's a good question. We see a decrease between 2005 and 2010. Do you think that's because of the 2009 recession?
Yeah,
See, those-
sure. There's a little blip here. Yeah. Wow.
Everywhere.
You got the eyes of an economist. There's another little blip here in 1976. What happened in 1976? Yeah. Economics, my man. That's economics right there. That's what economists do, is they look at stuff like this and then try to figure out why is that? And then look at what's happening.
So why is it?
I don't know. But he's proposing this is the 2008 recession, right? That's what the big recession of 2008.
How
It's
old
right
were you
here.
in 2002?
I was 6 years old.
You were 6, you know about that.
That's a good sign. He reads. Or watch a movie. Some way, somehow. Great.
Thank you, Javier.
You're welcome. My pleasure.
Nice.